All right, welcome back, everyone. We got 8.5, and we are going to be transforming sine and cosine functions today. So, your learning goals are to vertically, horizontally stretch, shrink graphs of sine and cosine. That is very brief, but a lot. So we are going to be we're going to be stretching them up and down, and we're going to be stretching them, kind of to the left and right. You'll see what I mean by that, okay? Now, we're going to start off with some introductory information, then we are going to do a Desmos, and then we're going to dive right in, okay? Now, there are two functions that we're focusing on are the sine and the cosine functions. We will not be doing tangent because it looks very different than these two. And these two are going to look very similar. Now, each of these is what we call periodic. It is a function, a function is periodic if it repeats at regular intervals, okay? So both of these will repeat themselves over and over and over again. The length of that repeating, we call the period, okay? Now the midline is a line between the max and min vertical values. So, if I have a sine function up here that looks like this, the midline cuts right between it, okay? And then the amplitude is the distance from the midline to the max or the minimum. So if it went up again and came down like this, and let's say we were here and this was 1, then the amplitude would be 1, okay? Now, I'm going to do a brief, kind of a parent function for both of these, okay? And we're going to go like this, a little table here. And we're going to have our input theta and our output f of theta. Okay. Now you're going to really need to remember back to the unit circle about this. I'm going to kind of draw, a small one. All right, let's just draw like a little circle right here. Let's split it into 4 parts. And if you remember, the point here was 1, 0, right? The point here was 0, 1. The point here was negative 1, 0. And the point here was 0, 1. Okay? These are going to be the most important points. All right? Now, there were degrees for this, right? That'd be 90 degrees to go to, 0, 1. But we also said that in radians, this was 0. This was half of pi. This was pi, this was 3 over 2 pi, and then back to 0 again also was 2 pi, okay? Because these functions, we are going to look at them in radians, okay? And these are really the numbers that we need to use for our input for theta. So we're going to start off with 0, and then pi over 2, pi, 3 halves pi. These are the worst looking pi's ever. And then 2 pi, okay? And then the same thing for this one down here. Okay? So 0, pi half, pi, 3 over 2 pi, and 2 pi. Okay? Now, if you remember, all the sine values were the y values. So at 0, our sine was 0. So that's 0, 0. All right. At pi over 2, it was 1. So that's 1. At pi, it was back to 0. So we're back to 0. At 3 over 2 pi, it was negative 1. So now we jump down to negative 1. And then back at 2 pi, we are at 0 again. So what does this look like on your graph? Well, we go up to positive 1. We went down to negative 1. We started at 0, 0. And we went all the way to 2 pi. Okay, let me change this color up here. Hold on. Let's get some blue in here. All right, we started at 0, 0. We went up, so up to 1. And then we go down, and at pi, we went back through 0. And we made it all the way to negative 1 at 3.5 pi. And then back to 0 here. Now, of course, this would continue, right? Go on and on and on and on and on and on forever, but we're really only looking at a single period, a single distance, where it goes from, right back to where it starts, because this is periodic, and its period here would be 2 pi, okay? So the period is 2 pi. All right. Now, that's what a sine function looks like, okay? And now I know there's an a and a b value here, and after I draw the cosine one, we're going to talk a little bit about how these affect the graph, okay? So, same thing here, right? We start at 0, 0. Cosine is the x value, so we already started at 1. See that red. And then at half of a pi, we were at 0. And then at pi, we were at -1. At 3.5 pi, we were at 0 because all the x values. And then back at 2 pi, we were at 1 again. All right. So this one's a little bit different. We start at 1, we go down to -1, right? We have our period, which we're going to want to draw this part first. So we got pi over 2 to pi to 3 over 2 pi, and then 2 pi. Okay. So we start at 1, 0, 1. So we're up here, and at pi and a half, we're at 0. And then at pi, we make it all the way to -1, just like right there. And then we cross back to 0 at 3.5, and then we make it back up to 1 at 2 pi. And so if we follow this, this is going to go down and up and down and up. And so if you look at the sine and cosine functions, they look like they're really just different stages of them, right? Because if you think about this, right, you look at it right here, if I looked at from there to there, well, that's the cosine function, right? They're really just kind of starting at different points. And so sometimes if I were to draw a cosine function, it could be hard to tell if it's a sine function that's just translated or moved over, right? So, you got to be very, very careful, okay? Now, this one also had a period of 2 pi, okay? And both of their amplitudes, because they went up to 1 and -1, that's a distance of 1 from the midline, so both of them had an amplitude, which is called amp, of 1, okay? All right, now, let's kind of refresh here. What actually made the amplitude 1? Well, that's going to happen with the sine value, or excuse me, with the a value here, okay? Whatever number that goes there is going to affect our amplitude. So if we had a 2 here, then the only difference about these functions is that they would have gone up to 2. Sorry, they would have gone up to 2. Gosh, come on. Up to 2. There we go. Up. It just does not like me today. I'm going to call that 2. Down to 2, and then back to 2 pi. So it would have stretched it vertically, but the period would still be the same at 2 pi. Okay? So this a value here, the a value contributes to the vertical, the vertical stretch and the shrink. Kind of, again, back to if I put like a 1/2 there, that would shrink the amplitude down. It would only go to a half, like this. Okay? If I put a negative there, right, that reflects it, it would go down and then like this. If I put a -1, right? Now the b value is something very different. The b value is going to tell us our amplitude, and it's also, in fact, let's do this in green so we can tell these apart. It's also going to do our horizontal shift. Oh, those are just poor choices right there. Okay. All right. Now, the way we find the period is with the formula of 2 pi divided by whatever b is. So if b is 1, because we just graphed this as if it was just, sine of theta, right? Or this was just cosine of theta, just very basic, a 1 for a 1 for b. If we would have put a number there for b, we would have had a different period. This point would be in a different place, right? If b is 1/2, that would have given us a period of 4. This would have been stretched all the way out to 4 pi before it repeated once. If b was 2, well, 2 pi divided by 2, that'd be 1 pi. This whole thing here would have happened before it got into pi. And of course, we're going to go over this in great detail, okay? I'm just trying to prime you guys because, look at how much information is on this page. And this is an introduction, right? There's a lot going on with this, all right? So I want to bring us full circle here, all right? Graphing the sine functions is related to the unit circle. You definitely need that unit circle to kind of understand how this happens. It is periodic. There's a period. It repeats. We have an amplitude that stretches it up and down, and our period is going to stretch it horizontally, okay? Now, picking these parent points are different based off the period, okay? So let me stop talking on this introduction. This has become much more than introduction, okay? What you should take away from this page is just the basic details, okay? Let's do a Desmos exploration. Let's see how that A and B really, truly, quickly shift it. And then I got 4 problems. It's going to be a super long video, so hang in there, okay? All right, so here we are on Desmos. I think this is going to be one of the more helpful Desmos explorations because I just gave you guys a ton of information really, really quickly, okay? So notice how we can see just how periodic a sine function is, okay? Now, if you look at the x values, they are numbers, so it doesn't look like it's in radians, but if you think about it, 2 pi, well, 3.14 is what we use kind of to abbreviate for pi. 2 times 3.14 is 6.28. And if you look at where 6.28 is for an x, you know, that's right where this crosses for that first time. So it is still in radians, okay? Now, we have an a value of 1, we have a b value of 1. Watch what happens as I increase the b value. You see how the amplitude increases, okay? Right? And notice how its period hasn't changed. It's still going right through 6.28 where 2 pi is, okay? Now, if I go below 1, see how it kind of, you know, it shrinks, it compresses, right? And then if I go to negative, see how it's going down instead of up from 0. It's just the opposite, right? It just flipped. See that? Look. Okay. All right, getting carried away there. All right. Now let's bring this back to 1. Okay. And then I have my b value. Now, we haven't seen what b does yet. Exactly. So watch the period. See how it's shifting out? Okay. We're just changing the period. It's going to the same height, right? But we're changing, you know, its periodic cycle. Okay. And this is that horizontal stretch. Okay. Now, believe it or not, this is exactly how radiation works, right? Your cell phone is sending signals that follow wavelengths just like this, right? And they can tell by the frequency of it, by how many times, they can tell who's sending the message or what kind of message is being sent by how many frequencies they can count in certain periods, okay? Now, I hope this kind of helps you see, you know, if I could just, you know what, let me quickly just change this to cosine. Let's do that. See if this will show real quick. Yeah, it worked. Okay, it's got a lot of parentheses, but it worked. It's the same thing here for cosine, but notice how it just looks like the whole thing is shifted over a little bit, right? And, you know, we think of it as starting from 1, okay? All right, and you know, a value affects it same way, okay? So hopefully kind of helped seeing it this time. We're going to dive in and we're going to do 4 problems, okay? Okay, so our goal here is to graph the trig functions over a single period. So we don't need to keep going over and over and over again. And we're going to identify the amplitude in the period, okay? And truly, that really should be your first step, okay? You should sit here first and go, what's my amplitude? Well, look for your a value. It's a 3. So boom, my amplitude is 3. And from there, you should go to your graph and you should put a positive 3 and a negative 3 instantly, okay? Because that is where it's going to rise to and where it is going to fall to, okay? The next thing is calculating your period. It is 2 pi over b. You don't see a b value, so b is 1, so our period is just 2 pi, okay? Now that's going to help us write out, you know, kind of how far our function really goes for a single period, okay? And you need to do this first, and it's going to be much more apparent when you do one where it has a different period on why we have to do that first. Now we have our distance of 2 pi, and so we you know, put in our 4 segments, which is really easy when you have a period of 2 pi, and you're going to see how hard it can get when you don't. And so I'm going to put my pi over 2, and my 3 pi over 2. Okay? Now the only difference between this one is just that it's going to go higher and it's going to go lower. So it's going to start at 0, 0. It's going to go up to 3, back through 0, down to negative 3, back to 2 pi. Boom, boom, boom. You're done graphing this one. Okay? Didn't seem so hard now, right? Okay. Let's do another one. Cosine. Okay? And you know, truth be told, I don't think there's really going to be any u-dos straight up in this one, because it's going to get pretty tough after this, just for calculating the period and writing that part out. Okay? Now, g of theta is equal to negative 2 cosine of theta, right? So this is going to flip it. Remember, if this was, you know, regular cosine function, we would start up high, go low, and come back up, okay? But because it's negative, we're going to start down here, and we're going to go up first, and then down, okay? So first thing we need to do is look at our period, or amplitude. Our amplitude is 2. I don't need to put the negative 2 there. The amplitude is just 2, okay? Think of it more as absolute value, all right? Now again, there's no b value, so my period is just 2 pi. So that's the first thing I need to do is go to my graph and put those things in. It goes up to 2, down to negative 2, right? It goes all the way to 2 pi. So we split, we take half, and we bring it into quarters also. Okay? Now, because it's negative, we're not starting up here, we're starting down here. And so we're going to do this in blue. I should go from negative 2, and at that first fourth, I should be crossing. Okay, at pi, I should get back up to 2. At 3.5, I'm crossing. And then at 2 pi, I know it doesn't look like I'm back at negative 2, but I should be right back at negative 2. Okay, that's what a cosine cosine function will look like, where it's also reflected and having vertically stretch for the amplitude. Okay, not too bad. Okay. Now, if you're struggling to see why I'm crossing it and when, think of it as kind of something happening at every fourth, right? I started here, so after moving a fourth through the period, I'm crossing, right? After moving another fourth, I'm back up to my amplitude. After moving another fourth, I'm crossing. After moving another fourth, I'm back to, you know, the end of my amplitude here, okay? And you should see it this way in 4 segments. In fact, if I kind of go back and see it here, look. You started at 0, I moved a fourth, and when I say a fourth, I mean a fourth of the way through the period. I'm at the height, I moved another fourth, I'm crossing, I moved another fourth, I'm back, I moved another fourth, I'm crossing. Okay, it's kind of like, and I don't want to say it changes directions every fourth because we're still going down when we cross through this one, but it should reach its next kind of destination, all right? All right, let's do some where the period is different, okay? Because here you can see we have a 2 for B, and that's going to change things significantly. All right, so our amplitude is 4. This is a sine function. So we have an amplitude of 4. We're going to calculate our period. So 2 pi divided by 2 is equal to just pi. So that means we do a full, you know, full back and forth every 1 pi now, not every 2 pi's. Okay. Now I'm going to draw my amplitude. I go up to 4, down to negative 4. I go all the way out to pi first here, okay? Not a 2 pi, just single pi. And I need to split it into 4 pieces, okay? Now, splitting pi into 4 pieces is a little bit easier than maybe some of the other ones will get, because that's really just pi over 4, right? Like every pi over 4 is a fourth, right? So, it doesn't look like, let's go right there, pi over 4, which if I add another pi over 4 is a half. Add another pi over 4, that's 3 pi over 4. Now there's a lot of ways to do this. You could sit here, and once you have your period, you can take half of it to get here, half of it again, add that half to get here. You could think about this so many different ways. I like, you know, whatever helps you break it into 4s. Okay? Now it's a sine function, so I'm starting at 0. I did cosine last one, right? Yeah, okay. So I start at 0. I should reach my amplitude, the height of it, okay? I should cross by the next fourth. I should reach my amplitude. I should get back. Okay, that should cross a pi. All right. Now, this function doesn't look much different than this one because we're graphing them on the same scale, right? So, I mean, this kind of looks, you know, the same, but if you notice that I'm just kind of putting 4 out here, just putting it out in the distance, out in the ether, right? But if I was making them all the same, like 1, 2, 3, right? And I drew them to that, you know, it would really look different, okay? Now, again, this pi is right here, but 2 pi originally, okay, was right here. So, you know, again, I'm adjusting kind of our graph here to be easy, but if I would have drawn it on the same scale here, we would have seen that it would have reached, whoops, you would have seen that it would have had to go right here. Like this is where what the other one, well, it goes up to 4. So this is what the other one would look like on this graph. So, you know, be careful here. It looks like I'm drawing the same one. This is generally how we quickly draw them, but they are all very different, okay? And that's kind of why I wanted to do that decimal exploration. I just kind of felt like it helped you really see it better, all right? Now, the last one, graph trig functions over one period, identify the amplitude and the period, okay? A little bit trickier this time because we have a third as our b value, okay? Now, this is a beta value. It's just kind of the same thing as a theta value, all right? But our b now is 1 over 3. Our amplitude is 2. So I got an amplitude of 2, have a period, well, I have to go 2 pi, zoom in over here, divided by 1 over 3. Well, now it's a little bit trickier, okay? So 2 pi over 1 divided by 1 over 3, keep change flip, and I get 6 pi, all right? So my period is 6 pi. Okay, now notice how a smaller number there, a dividing by 3, a 1 over 3, stretched our function out, okay? And I think that's key to understand here, right? Is if I would put a 2 there or a 3 there, just like not like a 3 over 1, not a 1 over 3, like let's say it was, you know, the function was this, 2 cosine, you know, of 3 beta, okay? Well, that would have been 2 pi over 3. That would have really shrunk it, right? So a bigger number for b would bring it closer together. Like, well, that just came to a circle. A bigger number for b would bring it closer together. A smaller number for b brings it further apart. Okay? All right. Now, we got an issue here, right? We got 6 pi, which will put it all the way out here, and we need to slice this into 4 pieces, okay? And it's a little bit trickier now because, well, it's 6 pi. How do I slice that into 4 pieces? Well, for starters, you could divide it by 4, okay? 6 pi divided by 4 is the same thing as 3 pi over 2, if I simplify, right? Or 1.5. And now that makes sense. 1.5 plus 1.5 plus 1.5 plus 1.5 is 6. So we're splitting this into a bunch of 3 half pies, okay? So my first one, it's going to be a fourth of the way as 3 pi over 2. Okay, now I can keep adding that to get to the next one. I can add it, you know, 3 pi over 2 plus 3 pi over 2, which would be 6 pi over 2, or just 3 pi. And that makes sense. 3 is half then 6, so it makes sense that 3 is my halfway mark. Then I'm going to add 3 pi over 2 to 3 pi. Okay, and that, you know, we could think of that as 4.5 pi. I know if you thought about it as decimals, but we tend to see radians with fractions more than we see decimals. So I'm going to keep it that way, right? And I'm going to convert, like if I had to do, let me write it out here. So 3 pi plus 3 over 2 pi, okay? I can convert that 3 to have a denominator of 2. So that would be, you know, 6 pi over 2 plus 3 over 2 pi, which will give me 9 over 2 pi. So 9 over 2 pi. Okay, now these don't look evenly spaced, but these are supposed to be evenly spaced. All right, in fact, maybe if I just like let me move this over. It looks a little bit better. Okay, all right, now this was a cosine function. It's gonna go up to 2 and negative 2, okay? Cosine functions start at they start at 1, but because this is an amplitude of 2, it starts at 2 up here, okay? So I'm going to draw it out. We're up here. Let's do this in green. Here's my first point. I go down through 3.5. I go up to 3. I go down through 9.5. I go boom, up to 6. And there it is, okay? Now, we got a lot going on with this, all right? If you're struggling with this, come prepared to class to ask questions. If you got it, hey, good for you, okay? Yeah, good for you. Don't know where I'm going with this, right? If you didn't get it, though, that's okay. I'm not going to lie to you guys. I think, the first time I saw these trig functions, it was really the first time in a math class that I really felt confused, okay? And if that's you right now, that's all right. Just don't give up. Keep working at it, figuring it out, and you're going to get there, okay? All right, everyone, I think that's all I got for you. I don't really have a math talk too much prepared for this, but I did talk a little bit about how we use these wavelengths to communicate, radio signals, cellular signals. I mean, these sinusoidal and cosine functions really are the building blocks to telecommunications. And I don't know about you guys, but I love my phone, and so I'm glad that somebody knows how to get these to send signals, okay? All right, you guys have a good one. I'll see you next time.